So in this video, and the next several videos, we're going to focus in on digital sound, how we represent these audio waveforms digitally on a computer or a compact disc or any other kind of digital media. We're going to talk about a lot of the issues that come up with that. In particular, in this video, we're going to look broadly at the differences between analog and digital sound and the different challenges that come up in each media. And then we're also going to take a little bit of a digression to talk about some of the implications of copying audio in analog versus digital domains and preserving it and archiving it. I want to start by talking about analog versus digital sound. And the key idea here is that analog is a continuous medium and digital is a discrete medium. So as kind of flagship examples of each recording media, let's think about vinyl records as being the quintessential analog audio media, and compact discs as being the quintessential digital media. So on a record, we have a needle that's reading from these grooves, and those grooves are going up and down. That's creating those different amplitude values that are being reproduced by a record player. So this is a continuous process. It's a continuous function. We can think of it as being, we talked earlier about a waveform as being a function. We can think about it as being, y equals f of x or something like that, where at any arbitrary continuous moment in time, there is an amplitude value to work with that. So that's in the analog realm with a record or something like that. When we move to the digital realm, if you think of the compact disc, we have a laser that's reading a bunch of zeros and ones off of our compact disc. Zeros and ones are discrete, and they're representing discrete moments in time, and discrete amplitude values at particular points. It's no longer a continuous function. It's a discrete function. So we decide what moments in time we want to record these amplitude values, and then we capture them at those moments, and we play them back at those moments. We know nothing about what happens from in between these discrete points in time where we're taking these amplitude samples. And so this is the key difference between analog and digital. This is continuous versus discrete. And just to kind of drive this point home, I want to go back to Reaper here. And this is a sine wave. And all I've done here is I've zoomed in basically as far as Reaper will go. That's maybe a little bit too far there. But you can see here these individual dots. And each of these individual dots represents one. Each of these, I'm not going to draw an arrow in every single one. Each of those represents an individual amplitude value that we've stored digitally, and so we're down to the lowest level of the digital representation here. As we zoom in further and further and further, we can see those individual samples that were captured. And of course, Reaper has done a nice job of kind of connecting the dots between them, but we don't really know what's happening in between them. We can just interpolate and we can kind of guess. So that's the key difference here, is this continuous versus discrete. So in the digital domain, if we're thinking about what is actually stored at each of these dots, there's a few different considerations that we need to think about, and these we'll be exploring in much more detail in the next few videos. The first one is sampling rate, which is how many of these dots are we recording every second. So this has to do with the horizontal, the time resolution that we're capturing. How many amplitude values are we recording every second? How fast do these dots come one after another? Bit width has to do with resolution in the amplitude dimension. How many bits of digital data are we reserving to store every single one of these individual amplitude values? So again, bit width has to do with what is our resolution on the y-axis of a waveform. Sampling rate has to do with what is our resolution on the x-axis. And the third thing is how many amplitude samples are we recording for each of these values? Because right now we just see a single dot for each of these, single amplitude value in our waveform view. But might we need to record 2 channels or 3 channels or 10 channels in order to represent the locations of sound in space? We may need to capture multiple amplitude values at each moment. So like stereo sound would have 2 channels, for instance. So these are the fundamental things we'll be exploring over the next few videos. But before we do that, I said I wanted to take a quick digression. It's not really a digression because it's really elemental to the differences between analog and digital media. And that has to do with how we copy these media. When you make a copy of a record, say if you're dubbing a record to a cassette tape or something like I did when I was a kid, it's not a perfect copy that you end up with because you're copying analog data. You're copying this continuous function. It's not going to be perfect. It's going through, it's essentially re-recording this data as it's being played back. In the digital domain, you're just copying a bunch of zeros and ones. And if you're worried you might make a mistake, you can go back and check again and again to make sure that you haven't made a mistake in all kinds of different ways. So digital copies are perfect replicas of the originals. There isn't really no sense of a master anymore because every copy can be perfect. And this has obviously had lots of implications on music sharing and piracy and legal ramifications. Once you can just rip a CD or share a file online, all of a sudden, and it's perfect, as opposed to the generational effects of making copies of copies of copies of analog media, it can become much more of an issue. But what I want to really talk about here is the implications of analog versus digital in a more artistic sense. And to demonstrate this, I want to show you a work by filmmaker Bill Morrison and composer Michael Gordon. It's called Light is Calling. It's written in 2004. And what Bill Morrison did here was he took some film footage from some early silent films that was in archives, and these film reels were starting to decay. If you put these into a projector, they might just disintegrate, or they might be able to play once or twice before they started falling apart. But the images were not as they looked originally in the 20s or 30s or whenever they were originally made. They're really transformed and dirty, and there's all kinds of noise. And sometimes it's impossible to tell what the original was. Sometimes you can make out little bits of it. And so he edited a bunch of stuff together from a silent film called The Bells for this piece. And then Michael Gordon composed, actually using digital sound, composed a soundtrack to go along with it. I think it's a beautiful film, and I want you to take a moment to watch it. What I think it really shows is how analog and digital media can decay in different ways here. Because here's this ancient kind of crumbling analog film reel that still contains some of the original information in it. Digital data doesn't degrade nearly as gracefully. If you lose your digital data, if it gets corrupted, usually you're just finished. You have no semblance of the original left to work with at all. And so this was another point I wanted to make in this relationship, and it's something I think is really taken advantage of quite effectively in this work. So to review here, in this video we talked about the basic differences between analog and digital sound as continuous versus discrete representations of audio. And we talked about those discrete samples of audio that we get in digital representation of sound, and the issue of horizontal resolution, of sampling rate, how many samples are we taking per second, bit width, the vertical representation, how much resolution are we using to represent each amplitude value, and how many channels of sound do we need. And we talked about some implications of analog versus digital sound in copying audio, and also in the kind of degradation and preservation of audio. So in the next 3 videos, we're going to delve into these 3 ideas of sampling rate, bit width, and channels in much more depth, and look at some of the details about how we decide what we need in each of those domains.